In today's video, we are going to be learning how to balance equations. This is going to be a huge skill that we are going to use throughout the year. So what this means is that equations have to be balanced in order to be in accordance with the law of conservation of mass. Again, law of conservation of mass says that mass must be the same before and after the reaction. So if we start with 100 grams, we have to end with 100 grams. Another way to look at this is we must have an equal number of each type of atom on both sides of the equation. So if we start with 10 hydrogen atoms, we also have to end with 10 hydrogen atoms. Now they might rearrange, they might be connected to other stuff, but if we start with 10 hydrogens and say 7 chlorines, we have to end with 10 hydrogens and 7 chlorines. So you have to have an equal number of each type of atom on both sides of the equation. So if we take a look at this example that we have right here, first thing we do is we split it in half at the arrow and we count up how many of our reactants we have and how many of our products we have. So what I mean by that is we count how many H's and how many O's we have. Right now with this 2 in front of the H2, that means we have 4 H's because we literally have 2 H2s. So therefore 2 times 2 would give us 4 H's. And we have 2 oxygen atoms. On the second side here, we have this coefficient. Coefficient is our number out in front of the formula, and that gives us our mole ratios. We have 2 H2O. So that 2, you can think of it being in parentheses. We have 2 waters. So that gives us 4 H's, 2 times 2, and that gives us 2 oxygens. So that 2 will distribute through, or you can think of it that you literally have 2 waters. So that would give us 4 H's, 2 O's. So this equation is already balanced because we have 4 H's on either side, 2 O's on either side. And once you have the coefficients, those are the numbers out in front, that gives you the mole ratio or the recipe for the reaction. So 2 moles of H2 need to react with 1 mole of O2 to produce 2 moles of water. What we are now going to do is work on balancing these equations. So first thing you do is you cut it in half at the arrow. Then you take an inventory of what you have if you had ones in front of everything. So if I had all ones in front of everything, I'd have 1 Na on my first side, the reactant side, and 2 O's. On the second side of the arrow, I would have 2 sodiums and 1 O. So I need to change these coefficients, these numbers out in front. So and all I can do is add more, I can't take any away. So if I want to get 2 NAs over on the reactant side, I would need to put a 2 in front of the Na there. Now that would change me to 2 NAs, so that's good. I'm headed in the right direction. All right, now I got to fix O. So I've got 2 O's, I only have 1 over here. So now on this line here, I need to put a coefficient. Remember, it's like that whole thing's in parentheses, so if I want to get 2 O's, I would need to put a 2 here. Now, unfortunately, that's also going to change my Na total. So Na would now be 4, and O would be 2. So O is good, but now I got to go back and fix Na again. So now I would have to put a 4 in front of the Na, and now I would be all balanced because I have 4 NAs and 2 O's. My coefficients would be a 4. I could either leave this blank or put a 1 and a 2. So what it means is 4 moles of Na react with 1 mole of O2 to produce 2 moles of Na2O. All right, second one, cut it in half at the arrow, count up what we have on either side of the equation. So right now I have 1 calcium. I have 2 oxygens because 1 here plus 1 here. So that gives me 2 oxygens. And H is 2. Okay, other side of the arrow. I'm going to count them up in the same order. I have 1 calcium. This 2 would distribute to everything inside of the parentheses. So that would give me 2 O's and 2 H's. So this one's actually all already balanced. So I either can leave them blank or put in ones. And in my next one, do the same exact thing. Cut in half the arrow, count up what we have on either side. Now, eventually, some of us will get really good at this, and you'll be able to do some of these in your head, and that's great. And some of us all year long will write them out, and that is great too. Doesn't matter as long as you're able to do them. Okay, so right now, on my reactant side, I have 1 aluminum, and I have 2 oxygens. On the product side, I have 2 aluminum, so I'm going to need to fix that. And I have 3 oxygens, so I'm going to need to fix that. We could start with either one. Let's start with O this time. Okay, so I have 2 and I have 3. So now this is kind of like finding a common denominator in math. If I have 2 and 3, my common denominator would be 6. So what I'm going to do is I'm going to try to set O equal to 6. So if I know I need 6 O's, I would need to put a 3 in front of O2. That would give me 6 O's. Then, again, it's like that. It's in parentheses, and if you want to put that in parentheses to make it easier for you, go for it. Okay, I've got 3 O's. If I know I need to get to 6, I got to put a 2 here. So that would give me 2 times 2 for aluminum, so 4 for aluminum, and 2 times 3, so 6 for oxygen. So oxygen is all set, and in order to fix my aluminum, I have 1, I need 4, so I go to the side that I have less, and I put a coefficient in front, so I'm just going to put a 4 out in front, and then everything is all good. So 4 aluminums react with 3 O2s to make 2 Al2O3. All right, we have 2 more left, so hopefully you're starting to get the hang of this. If you want to try to pause the video, see if you can figure it out on your own, go for that. If you want to continue working through with me, you can do that too. All right, so right now we have 1 Na, we have 2 H's, and we have 1 O. On the other side, I always try to take them in the same order so that it's easier to compare them. I have 1 Na. H would be 3 because I have 1 here and 2 here. So 1 plus 2 equals 3. I also like to write it out like that so that I remember that they're in 2 separate locations. And then O is only 1. Now, normally I would tell you to wait on H because H is going to be a little bit trickier since it shows up in 2 spots on the product side, and that just makes it a little harder to work with. But Na is already balanced, and O is already balanced, so we have to start with H. All right, this is a trickier one. We are not going to set H equal to 6 because it shows up in 2 spots, and we don't necessarily need to change both of those. We need to change only one of them. So I know this single H is going to give me problems because over here it's H2. So therefore I can only ever have an even number if I use whole number coefficients. So I know I'm going to need to get rid of that single one. So if I put a 2 on this line, that changes Na to 2. It changes those H's to 2, which gives me a total of 4, and it changes O to 2. And it kind of looks like I made everything worse, but I really didn't, I promise. All right, so now if H is 4, on this side we have H2O. So if I put a 2 out in front of H2O, that's going to change H to 4, O to 2. So I'm in pretty good shape. All I need to do is fix Na. I plop a 2 there, leave that blank or a 1, and then I'm all set. So that was a little bit of a harder one. All right, our final one. This one's actually easier than the previous one. It just looks a little bit harder because there's more stuff there. So go ahead, take your inventory. I am going to erase some of that so that I just am not as crowded in there. So I got 1 lead, I got 2 chlorines, I got 2 aluminums. Sulfur would be 3. So this 3 distributes to the S and to the O. O would be 12 because there's literally 3 SO4 groups. So SO4, 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 so that would give me 12. So you're going to multiply those. When you take your inventory, I highly recommend doing it in the same order on either side so that when you're comparing them, it's just visually a little bit easier. So I got 1 lead over here. I got 3 chlorines, so that's going to be something I need to fix. I have 1 aluminum. That's going to be something I need to fix. I have 1 S. I'll need to fix that, and I only have 4 O's. Okay, so basically I can start with anything other than lead. Lead is already balanced, so I don't want to start with that. And all my other stuff only shows up in one spot on each side, so it really makes no difference what element we work with first. So let's just go in order. Chlorine. I got 2 here, I got 3 here. So they each only show up in one spot, 2 and 3, so I'm going to need to set them equal to 6. So I'm going to have to put a 3 here, because that would give me 6 chlorines. So again, if I want to get chlorine to 6, I would need to put a 2 in front of the AlCl3. That would give me 6 chlorines, also 2 aluminums. So chlorine is good, aluminum is good. Let's go back and fix lead. Lead is 3, only 1, so I got to put a 3 in front of the PbSO4. That's going to change Pb to 3. That's going to change S to 3, and that's going to change O to 12. And lo and behold, yay, I am all balanced. Again, in front of the aluminum sulfate, you can leave that as a blank or a 1.